All right, welcome everybody to SAT Math Crash Course Day 1. This is Part 1. I'm Mr. Tui, and we've got Caden joining us on the recording today. Say hi to everyone, Caden.
Hi, everybody.
All right, thank you. So real quick before we get started, I want to orient you to sort of the nature of this course and what I have planned. First of all, I've got good news for anybody struggling on the SAT. Which is that this test is not nearly as hard as everybody thinks it is. There's a lot of strategies that I'm going to teach you in this class today that really simplify the questions on the SAT. There's very little algebra you need to know on this test, very little higher level algebra. Using some strategies you can that I'm going to show you, you can plug in values in place of the variables and turn pretty much any algebra question into arithmetic on the SAT. And you can use a lot of just basic estimation for these questions that kind of simplifies everything. I'm going to show you how to do that. So we've got a question here on the screen. Before we jump into this question, I want to go over my rules for SAT math. Caden, you have access to those, I believe?
Yes.
All right, and I'd love you to read rule number 1 for me, please, on my rules for mathing.
Avoid algebra whenever possible.
And keep reading.
Instead, plug in values for the variables and solve.
Excellent. Okay, so I would say there's probably only about 4 or 5 questions in every SAT that require a specific algebraic operation. The vast majority, you can turn all those questions into arithmetic by plugging in values in place of the variables. I'm going to show you what that strategy looks like here. And it's the most powerful strategy by far that I can teach you for the SAT, that we're going to spend really the first 2 days of the course just focusing on that strategy. I would say it applies, Caden, probably applies to about 30 to 40% of the questions that you see in the SAT, that plugging in values for the variable strategy. Super powerful. Yeah. Okay, and then go ahead and read rule number 2, please.
Eliminate incorrect answer choices using basic logic. For word problems, remember that you are dealing with real-world problems and real-world solutions.
Yeah, I think you're going to be really surprised, Caden, by the number of questions where you can just sort of look at an answer choice and be like, well, that value just seems way too big, or like, that value seems way too small. Or if you start thinking in really concrete terms, like, that just wouldn't work in the real world. And if you can think in those terms, then, boy, you can eliminate a lot of incorrect answer choices, and you're going to see on some problems you can actually eliminate all the incorrect answer choices by just thinking in really concrete terms. Tap into your common sense. You can actually use that on this test. Because all of the questions are real-world sort of questions with real-world solutions, and all the values actually have to work in real life. So use that common sense, and sort of a way of approaching math that most students probably aren't used to. Most students, I think, sort of taught to, if they see a math question, like recognize the operation that's being tested on, and then follow like the 7 steps. And it's just not like that in the SAT. You can use a lot of common sense, and I'm gonna teach you how to do that. Okay.
Okay.
All right. So let's start with question number 1. We see it up on the whiteboard. Go ahead and read question number 1 for me, please.
If x minus 1 divided by 3 equals k, and k equals 3, what is the value of x?
Okay. All right, so it's pretty clear, right? This is an algebra question, right? They want you to solve for x, right? And there's a way to do it. Using algebra, you can do that, plug in that 3 for k, right, and then sort of isolate x. Would you feel comfortable doing that, Caden, or not so much?
I could, but
yeah, and you probably know at least that you're supposed to do it that way.
Yeah.
For anyone watching the recording, if you know how to solve it that way, you can. It's an option. I'm 100% cool with you doing whatever gets you the right answer choice. Like, that's sort of the name of the game. Do what works. But if you struggle with algebra, or if you just want to guarantee that you're going to get it without messing up an operation, there's a really simple way to do this by plugging in values for the variables. Look at all the answer choices here, Caden. Look at this. Right?
All right.
We know x is going to either be 2 or 4 or 9 or 10, right?
Yeah.
One of those has to work. So we can plug in that 3 for k, and then plug in the answer choices for x, right, and just test and see which one gives us a true statement without doing any algebra. Does that make sense?
Yeah.
Okay, so let's do that real quick. I'm going to do that here on the whiteboard. And, all right, so let's start. I'm going to plug in that 2 in place of x, so we get 2 minus 1 over 3 equals 3. First of all, does it make sense where all those terms came from?
Yes.
Okay, I'm testing answer choice A, so I'm assuming that x is 2. We're going to see if that works. And I plugged in that 3 right there. That was in place of k. Okay. All right. So does that give us a true statement? Yes or no, Caden?
No.
No, it does not, because what do we get on the left-hand side of the equation?
Well, we would have to subtract 1 from 2.
Yeah.
And that would leave us with 1, and you can't really divide 1 by 3. And
Yeah, and get 3, right? We get 1/3 equals 3, which is just not a true statement. Does that make sense?
yes.
All right, so we can eliminate answer choice A. That's gone. And let's test answer choice B. All right, so I'm going to plug in a 4 in place of x right there. So we get 4 minus 1 over 3 equals 3. Okay? Does it make sense where I got all those terms from?
Yes.
Okay, again, I'm just plugging in that answer choice B, that 4 for x. Okay. All right, so does that give us a true statement, Caden?
No.
No, it does not, right? What do we get on the left-hand side of the equation? What's that give us?
It would just give us another 3, and then we would divide and have 1.
Yeah, we get 3 over 3, which is 1, not 3. Those are not equal, so we can eliminate answer choice B. Any questions about that, or are we good?
I got it.
Okay, awesome. All right, so what about answer choice C? Let's plug that guy in. We'll get 9 minus 1 over 3 equals 3. Does that give us a true statement, Caden?
Yes, sir.
No, right? What do we get on the left-hand side of the equation? What do we get?
We would only get 8 over 3.
8 over 3, which is not equal 3, right? So answer choice D is looking pretty good. I hope that works out. Let's plug that in place of x. We get 10 minus 1 over 3. And what does that equal?
That gives us 3.
That does give us 3, right? Because we get 9 over 3, which is indeed 3. We can confirm it is answer choice D. Any questions about that?
I've got it.
Okay. How much algebra did we do there, Caden?
Very little.
We did no algebra. We did 0 algebras in that question. And now again, there's a small number of questions where yes, you do have to carry out a specific algebraic operation, but you're going to see a lot like this where you can just plug stuff in and test answer choices. And how confident do you feel that the correct answer is D? How confident?
100%.
100% confident, right? And that's the beauty of this strategy, right? Is that there's nothing really to mess up as long as you can do arithmetic, right? Like we've done
Right.
2 different things. We've eliminated all the wrong ones that we know don't work. And we've confirmed the right one. I mean, you can feel 100% confident that you found the right answer choice here. Okay?
Cool.
Any questions?
No, sir.
All right, let's go on to the next question. Okay. Go and read question number 3 for me, please.
All right. On Saturday afternoon, Armand sent M-text messages each hour for 5 hours, and Tyrone sent P-text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon?
Okay. All right, thank you, kid. All right. Do you feel pretty comfortable working with variables like this? Like, do you have a sense, maybe thinking in algebraic terms, what the right answer choice might be here?
Somewhat.
Okay. If you were going to guess what the right answer is here, what would you guess, based on your understanding of algebra?
Let me read over this really
Yeah,
quick.
yeah.
Just kind of get a better idea of it.
And some students are, feel really comfortable. They just look at this and they kind of know what the right answer is if they're familiar with algebraic operations. If that's not you, and by the way, it's not a problem. So I'm going to show you exactly how to solve this without even thinking about algebra. Okay.
All right.
So let's just jump right in. Yeah, let's just jump right into that. So instead of dealing with variables here, again, we're gonna plug in values in place of the variables. Let's create a value for m. Okay, the number of text messages that Armand sends each hour for 5 hours. We could pick a lot of different values. We could do 2, 3, 4, 5. We could do that. I prefer smaller values when possible. It's just going to make the arithmetic a lot easier. Does that make sense?
All right.
Okay. So let's make m. Let's make m equal 1. Okay? So this means now, Armand didn't send m text messages each hour for 5 hours. He sent 1 text message each hour for 5 hours. Does that make sense?
Yes.
Okay, good. All right, and Tyrone sent p text messages each hour for 4 hours, but I don't want to deal with p. I don't want to deal with any variables. Let's come up with a value for that. Let's set p as 0. 1s and 0s are great. They're going to make the arithmetic very, very easy. Okay?
Okay.
All right. Now, what is the question asking us to solve for here, Caden?
To solve for the total number of messages.
Yeah, the total number of messages sent by Armand and Tyrone. I coach some students to underline the last sentence of every question. You'll find everything you're solving for is in the last sentence of every question, certainly on word problems. So focus on that. Okay, let that guide you. All right, so we need to find the total number of messages. So let's talk about this just logically. If Armand sent one text message each hour for 5 hours, and Tyrone sent 0 text messages each hour for 4 hours, how many messages total did they send?
So only 5.
Only 5 total. Okay, does that make sense?
Yes.
Okay, great. So we know when we plug in a 1 for M and a 0 for P into the answer choices, the correct answer choice has to give us 5 total. Does that make sense?
Yes.
Okay, great. Well, let's do it. All right, so plug in a 1 for M and a 0 for P. Go and do that on the whiteboard, if you will, actually, please.
So just like got out.
Yeah. Go just find a clear space there on the whiteboard, and we'll test answer choice A, right, by plugging in a 1 for M and a 0 for P.
So 1, and then for
answer choice A, yeah. So it'll look like 9 times 1 times 0.
Oh. Okay. So for each of the hours. I'm sorry. So 9 times. Ooh, my handwriting's a little bit bad.
Yeah, you're good.
Sorry.
You're good.
Times 1. What would it be? So 9 times 1 times 0. That would it be?
Yeah, 9 times 1 times 0. Yep.
Right. Times 0. All right.
Okay. Does that make sense? Like this, I just want to clarify, that this statement, right?
Yeah, I see what it is.
Yeah, like 9. I just want to make it clear for anybody watching the recording that 9 MP means 9 times M times P. Does that make sense?
Yes.
Yeah. So when M is 1 and P is 0, those are equivalent expressions. 9 MP is the same as 9 times 1 times 0 when M is 1 and P is 0.
Right.
Okay. So what is that statement? What does that equal? 9 times 1 times 0.
So that would just equal 0.
No, you're absolutely, yeah, it's 0. It's 0. Anything times 0 is 0. Anything 0 times is 0. Okay. If I go to the store 0 times for 4 weeks, how many times have I gone to the store? I've gone 0 times. Anything 0 times is just going to always be 0. Does that make sense?
Yeah.
Okay, so it's not answer choice A. We know it's not answer choice A because the correct answer has to give us 5. So A is gone. Any questions?
Got it so far.
Okay, great. All right, so I'm going to clear that one, and then go ahead and plug in those values for M and P. We're going to test answer choice B.
Okay, so 20 MP. So it would be 20. Ooh. So 20. Wait, 1.
Yeah, M is 1. Mm-hmm.
Right.
And what does that give us?
That would just, again, 0.
Yeah, 0, right? Again, anything times 0, we got that 0 right there. It's going to be 0, so answer choice B is gone. Let's test answer choice C.
All right, so 5. So it would be 5 times 1.
Mm-hmm. Yep, 5 times 1.
5 times 1 plus 4. 0. Or 4 times 0. Ooh, that looks like a 9.
I got you. And so what does that equal here?
Ooh, that's even worse. So that would just equal 0 again, right?
Well, here's the deal. So
No,
we've got,
got that.
yeah. So we've got. I mean, these are kind of like two separate terms, kind of, right? We've got the 5 times 1, and then we're adding that to 4 times 0.
Right.
Okay. So this is actually where we can start talking about order of operations. Are you familiar with that? With PEMDAS? Have you heard that?
Yeah.
Okay, right. Parentheses, exponents, multiplication, division, addition, subtraction. Most students are familiar with that. If not, I can include a section on that in my rules for mathing. I don't have it yet, but I may be including that. In fact, I will be including that on my rules for mathing. So before we do any of the addition, we got to do the multiplication first, following that order of operations. So this is 5 times 1. What's 5 times 1?
5.
5 times 1 is just 5, and then plus, what's 4 times 0?
0.
0, right? And what does that equal?
5.
That equals 5. So that looks pretty good. We'll keep answer choice C. Okay? Does that make sense?
All right.
All right.
Yeah.
All right, so let's plug in 1 for M and P for 0 in answer choice D now.
Okay.
Doing great.
4 times. Ooh, what just happened? 4 times 1 and 5 times 0. All right.
Looking good. All All right, and what is that? So let's do the same thing here, right? Order of operations before we do any addition or subtraction, right? In PEMDAS, the addition or subtraction are right at the end of PEMDAS. That we've got to do the multiplication first. So what's 4 times 1?
4.
4. And what's 5 times 0?
0.
0. So we get 4, not 5. Answer choice D is gone. We can confirm it's answer choice C.
Huh.
Any questions about that?
I don't think so.
No? Okay. How much algebra did we do there?
None.
We did 0 algebras on that one. Just not necessary. You don't even have to think in algebraic terms. In fact, I prefer that most students don't. If you're really comfortable with it, you see this question, you know what the right answer is, you just get algebra, wonderful, do whatever works, do what gives you the right answer, but you're guaranteed to get it using the strategy of plugging in values for the variables. Okay?
All right.
All right. And by the way, all these questions that we're going to work on today, at least in this first half, are from like SAT practice test number 1. They're from the first section, the first math section. So I'm not just like picking and choosing like the easiest ones from all the practice tests. Like we're just working on one practice test here
Okay.
that all this strategy applies to all these questions. Okay?
Sounds good.
All right. So let's go to the next guy. All right, question number 4 is up on the screen. Go ahead and read question number 4, please.
All right. Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation?
Okay. All right. Caden, what do we? Yeah, a lot going on there. A lot going on. Let's try to focus a little bit here on what we're solving for. What are we solving for in this question?
It would be P and D.
Well, what are they asking? What are they asking us to find?
Oh, the number of phone. Wait, the value of 108.
There we go. Let that guide you. Okay. Again, it's the last sentence in every question on these word problems.
Okay.
What is the meaning of the value 108 in this equation? Does that make sense?
Yes.
Okay. Now, Caden, if you're anything like me, and I would argue probably anything like most students, just by looking at this equation here, I don't know what 108 means. I don't know. And I remember seeing this question for the first time and being like, I don't have a freaking clue, right? Like it's not, like algebra is not as intuitive as you would hope. In fact, it's not intuitive at all. Very rarely is like what looks like it might be the case is the case. Very rarely. Right. Okay. Which again was why I recommend so much thinking in concrete terms. Okay. So let's not even worry about the equation right now. Let's just focus on the meaning of the value of 108. Okay. And let's look at the answer choices. And this is where I want to go back to rule number 2, right? Which is that, in fact, let's read rule number 2 again. Can you go ahead and read rule number 2 one more time for me, please?
Eliminate incorrect answer choices using basic logic. For word problems, remember that you are dealing with real-world problems and real-world solutions.
Yeah, absolutely. Okay, so let's just focus on the meaning of the value 108. Let's think what would work in the real world. Okay? All right. Go ahead and read answer choice A for me, please.
Kathy will complete the repairs within 108 days.
What do you think about that? Is that at least possible in the real world?
Well, I'm not really sure, honestly.
Yeah. If we can't eliminate it, let's keep it.
All right.
Let's keep it. Let's keep it. Answer choice P, go ahead and read that for me, please.
Kathy starts each week with 108 phones to fix.
Okay. Is that at least...
That would...
Is that possible in the real world?
I'm not sure. You would need a lot of people with broken phones.
That's a lot of phones, right? But I think it's at least possible.
Yeah, it's somewhat possible.
It's possible. If we can't eliminate, don't eliminate it. Okay?
All right.
Don't. But take a look at answer choice C.
Kathy repairs phones at a rate of 108 per hour.
I want you to think about that for a minute, Caden. Think in real world terms. Okay? Don't worry about algebra or that equation or anything like that. Do you think Kathy or any human being could repair phones at a rate of 100 per hour, 108 per hour?
Yeah, no offense to Kathy, but I don't think
that's I doubt that's possible. I mean, that's just an insane number of phones per hour. Like we're talking, that's more than a phone per minute, right? And that's almost 2 phones per minute. So we're talking like a phone every like 35 seconds. Like she's just like flying through and give it that one. Like that's just crazy, absolutely crazy. Can we agree on that? Okay, it's when you think about it in concrete terms, like it's laughable that that's even an answer choice. Laughable. Okay? Gone.
All right.
All right, but I guarantee, like, kids across the country, there were probably tens of thousands or hundreds of thousands of kids that picked answer choice C just because. They just picked something random, didn't know. All right, so just get rid of that, think in concrete terms. What about D?
Kathy repairs phones at a rate of 108 per day. That's still pretty fast.
That's really fast, man. That's really fast. Boy, that's just... I'm very suspicious of answer choice D.
Yeah.
Like, let's say she's working an 8-hour day. We're still talking, like, I don't know, 12 phones an hour. That's 5... Something like that. It's like 5 phones a minute. I'm just estimating here. I don't know the exact values, right? But, like, that's... Or not 5 phones a minute. 1 phone every 5 minutes. That's still just a lot. I'm very, very suspicious of answer choice D. I'm tempted to eliminate. Do you mind if I eliminate right now? That just seems seems pretty crazy.
Improbable.
Okay. Yeah. Okay. So I think it's either A or B, which it is here. Okay. So now let's go back to the first strategy that I taught you of plugging in values in place of the variables, because we don't have to just like stare at the equation and hope the answer hits us in the face. That's not going to work. So let's come up with a value for D, the number of days she's worked. Okay? I just want to test things. I want to see, I'm plugging some values for D. I want to see how that affects the number of phones she has left. Okay? So let's start with D equals 1.
All right.
Okay? So I'm going to plug that into the equation in the question. And when D is 1, that'll tell us how many phones she has left after she's worked 1 day. So that's going to be P equals 108 minus 23, not times D, but 23 times 1. I want you to stop and take a look at that, Caden. Does that make sense what I've done here?
Yes.
Okay, I'm just plugging in that one in place of D. Okay, and don't just be like, okay, I plugged in one for D, right? Like, think about what it means. Okay, this means Kathy has worked 1 day, right?
Yeah.
Okay, and we know that when she's worked 1 day, we can find out how many phones she's fixed after she's worked 1 day. How many phones does she have left to fix, I should say, after she's worked 1 day? You can use your calculator if you want to, but if you know the answer, you can just tell me.
So I would just do the subtraction, right?
Yeah.
So then that would be...
It's just 108 minus 23, right?
All right, so 85.
85, right? After she's worked 1 day, she has 85 phones left to fix. Does that make sense?
Yes.
Okay. Let's try it again. Let's try it. Let's make D equal 2. So I'm going to be here just to the left of the question. D equals 2. I'm going to plug in a 2 in place of D into the equation. So P equals 108 minus 23, not times D, but 23 times 2. So what's 23 times 2?
23 times 2 would be 46.
Yeah, 46. And then 108 minus 46.
That's 62.
So P equals 62. So this means, Caden, when Kathy's worked 2 days, she's got 62 phones left to fix.
All right.
Is this starting to make sense?
Yes.
Okay.
So we're just going through each...
We're just making it concrete. We're thinking in terms of actual values and not just in terms of like theoretical variables.
Okay.
Okay. Do you see how many phones she's fixing per day? Because I think I see how many phones she's fixing per day now.
Yes.
How many phones is she fixing per day? Right. After she worked 1 day, she has 85 phones left to fix. After she worked 2 days, she has 62 phones left to fix. How many phones is she fixing per day?
So 23.
23. Right. And now we see the meaning of that value 23.
Right.
In the equation. That makes sense now.
Yes.
Okay. All right.
Oh, so then we could just use that to eliminate the last answer, right?
Well, we're going to find out here in just a second. But let's do this. Do you think, by the way, is she going to complete the repairs in 108 days?
At this rate, no.
At this rate, I don't think it's going to take her much more than 5 days.
Yeah.
Right? Like, if she's fixing 23 phones per day, it's going to take a lot less than 108 days. No, I mean, it's a true statement that she is probably going to repair these phones within 108 days. That's a true statement. I'm not sure if that's the meaning of the value 108. Okay? Yeah. Let's do this. I'm going to plug in a 0 for D. Okay. Plug in a 0 for D. Which means she's worked 0 days. She's not worked yet. It's the beginning of the week.
Okay.
Does that make sense?
Yeah.
Okay. All right. So P equals 108 minus 23 times 0. How many phones does she have left to fix after she's worked in no days?
108.
108. Answer choice A or B?
B.
Answer choice B.
Yeah. Oh,
Any questions about that?
I got it.
Okay.
That's cool.
Okay. Yeah, and it's real different. Like, I mean, I don't want to like talk about like theoretically like how variables affect an equation or like, I mean, you can do that. But the more you think in real world terms with actual values, you realize like you don't need anything fancy to figure this out. You don't even have to know algebra much. Just use common sense once you're dealing with real values. Okay.
Right.
Now, I mean, it took us a while to solve that, right? But you know, if you're working this thing on your own, just like you got to look at these questions like experiments. See what happens when Kathy works one day. How many phones she has left to fix? See what happens when Kathy works 2 days. How many phones she has left to fix? See what happens. If she hasn't worked any days, to test answer choice B. Right? Just test it. Look at it like an experiment and not in like what's the right operation. The more you think in those terms, like you're gonna look at all these questions and you'll be like, I don't know what I'm supposed to do. I've never seen this question before. I've never seen a kind of question like this before. And with practice, they'll get more and more familiar. But you know, seeing it for the first time, it's not obvious what to do. But that's okay. Just look at it like an experiment, and again, think in concrete terms, and you can figure any of this stuff out as long as you can do arithmetic. Okay?
Yeah.
All right. Question number 6. I like this question. All right, go ahead and read question number 6 for me, please.
A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Okay,
let's make it really, really clear, Caden, right off the bat. What are we solving for here in this question?
The estimated increase in inches of a boy's height each year.
Yes. Again, it's that last sentence in every question. Do you see that?
Yeah.
Okay, let that guide you. Okay, so we're going to find the estimated increase in this boy's height each year.
All right.
Okay, before we start worrying about that equation, or even plugging in values, let's start thinking in logical, concrete terms. Okay? Do you have little brothers and sisters? I think you do, right?
Yes.
Okay. How old are they?
My little sister is 7 and my brother is 10.
Okay. Do you have any concept of like how much kids grow every year, especially little kids between the ages of 2 and 5? Do you have any concept of that?
No.
No. Okay.
Well, I mean, a very small amount.
I mean, yeah. I mean, it's like they grow, you know.
Yeah.
But like, how much is it? Like
probably not 14.
Probably not 14.3 inches. And thank you, God in heaven above, that they don't grow 14.3 inches per year, right? Because if a kid's growing that fast at 2, let's say he's like 2.5 feet or like something like that. I don't even know exactly how tall. And I've got like a 3-year-old at home, but so I should know this. I don't know how tall she is. Sorry, there, Abigail. But anyway, but if she's like 2 or 3 feet tall, like if she's growing 14.3 inches per year, by the age of 5, she's going to be like 6 feet tall.
Yeah.
Right, a 6 foot tall 5-year-old, which is that's absolutely terrifying. Okay, so right off the bat, I can eliminate answer choice D. There's no question about it. Does that make sense?
Yes.
Okay, let's go on. Any other answer choices that just look very suspicious?
Yeah, well, C's kind of up there with D.
I think C is right up there with D as well.
It's really growing 9 inches, like, unless something's going on.
That's too much, yeah, without like some like glandular disorder or something like that. Like that's almost a foot per year still. It's not as much as 14.3, but that's still a lot. We're still talking like, you know, a 5 foot tall 5-year-old. You know, that, yeah. And you know, and if they continue at a rate even similar to that as they get older, I mean, it's just, again, it's very, very improbable. So we can eliminate C and D right off the bat. Okay. B looks like a lot, but I'm going to leave it. I don't know with any certainty. Okay. I mean, I'm not an expert on just the growth of children per year, but I think just using some common sense, we can eliminate C and D. Does that make sense so far?
Yes.
Okay, good. Now, let's go back to that first rule, right? Again, of plugging in values in place of the variables.
Right.
Okay? And this is the beauty of sort of rule number 1 and 2. They really work in combination together. You can think in concrete terms and start eliminating answer choices, and you can start plugging some values and think in even more concrete terms and even eliminate more answer choices, right? Does that make sense? So let's do that. Let's start. We're trying to find how tall this kid grows every year between the ages of 2 and 5. Okay? So let's plug in some values for A, right? We'll find out how tall this kid is when he's 2, right? Because the A is the age and H is the height. So if we plug in a 2 for A, we'll find out how tall this kid is when he's 2, right?
Okay.
And then we'll plug in a 3 for A and find out how tall he is when he's 3, and we'll see what the difference is.
All right.
All right? Does that make sense?
Yeah.
And we do the same thing to see how tall he is when he's 4, and just see how much he grows every year. We don't have to think about it theoretically. We can make it concrete. Okay? All right, so let's do that. So I'm going to plug in. You can help me calculate it. I'm going to plug in A. We'll start with 3. A 3 for, I'm sorry, we're going to start with 2 for A.
All right.
We're going to make A equal 2. That's 28.6. Do you have a calculator handy?
Yes.
Okay. So how tall is this kid when he is 2, when A is 2?
So. Wait, would it be the 3 times 2?
Yeah, 3.
It's been a minute since I've done
Yeah, you're good. Yeah. So that are you wondering what the parentheses mean?
Yes.
Yeah. That just means multiplication. Mm-hmm.
Right. So then plus. So then it would be 34.6 inches.
Okay. Sounds about right. All right. So when this kid is 2, he is 34.6 inches. Let's make A equal 3. We'll find out how tall he is when he's 3, and what's the height when the kid is 3.
It is. Wait. Oh, totally messed that up. My bad.
You're good.
37.6 inches.
Yeah, because that's 3 times 3 plus 28.6. You said it was 30.
37.6.
37.6. Let me just scroll over here a little bit on the whiteboard. All right, so it's 37.6 inches when he is 3 and 34.6 inches when he's 2. How tall is this kid? How much is this kid growing every year?
Like 3 inches.
3 inches. Is it A or B?
So it's A.
It's A. Now again, we could test again. We could plug in a 4. Okay, let's do that. Let's plug in a 4. So yeah, I mean just to be certain here. So that's 3 times 4 plus 28.6. Go ahead and calculate that real quick.
So 40.6 inches. And again, it's
What's the increase there?
3 inches.
3 inches increase. So we can confirm it. It is indeed answer choice A. Any questions about that?
No, it makes sense.
Can you solve a question like this with your current skill set?
Yes.
Absolutely. I don't want to teach you any new math, really concepts. We could brush up on your arithmetic a little bit, but we're not going to any algebra lesson or anything like that here. So what I'm really trying to teach you here, and anybody watching the recording, I'm just trying to teach you a mindset, a way of approaching the questions that simplifies this whole thing. You're just thinking really, really basic, concrete terms, tap into your common sense, turn the stuff into arithmetic, and you can solve almost any question on the SAT. Okay?
Got it.
All right. Let's keep going. Ooh, I like this question. I like all these, actually. A little bit of a nerd. All right. Go ahead and read question number 8 for me, please.
All right. If A over B equals 2, what is the value of 4B over A?
Okay. Caden, I remember seeing this question for the first time years ago and being so confused and not having any idea what to do. And I'm guessing it might be similar to how you're feeling right now.
Yeah.
Is that a fair assessment? Yeah. Okay.
Yeah.
I mean, it's a lot of variables. It's definitely involving some algebra. Looks a little scary. There's a very, very simple way to solve this. Take a wild guess what strategy we're going to use to find the right answer.
Probably just plugging in values.
We're gonna plug in values and place the variables. Absolutely, yeah. Absolutely. All right. So I need a value for A and a value for B that we're going to plug in, right? Because we're trying to find the value of this 4B over A. I need a value for A, a value for B.
Right.
So give me a value for A.
So when when we would do the values, we probably want to go low, right?
Yeah, I mean, the lower the better in general. Okay, and if you start low and you can only eliminate like one or two answer choices, then you need to increase the size of the values. That's fine, but start low.
Okay.
It's going to simplify things. So give me a value for A and a value for B.
So value for A would be like 2, I guess.
Yeah, we'll make A 2. And what are we going to make B?
1.
1. Absolutely. That's going to work beautifully. Okay. Now, some students, when I work with them on this question, they'll be like, okay, let's make A 3, and we'll make B 2. Why can't I use 3 and 2?
Because it wouldn't divide into equaling 2.
Because I gotta pick values. Right? I'm somewhat limited by the types of values I can use here.
Yeah.
Do you see that? Like, I can't just pick anything.
Because it just wouldn't work.
It wouldn't work there. Yeah, I've got to work within the limits of the question. Okay, I've got to pick values for A and B such that A divided by B gives us 2. Okay.
Right.
So 3 and 2 wouldn't work. We got to do something like 2 and 1 will work just fine. I could also pick like 4 for A and a 2 for B. That would work. I mean, if I wanted to, I could do 8 for A and 4 for B. As long as A divided by B equals 2, as long as I get that, then I can pick any value for A and B, and it's going to work out just fine. Does that make sense?
Yes.
Okay, good. All right, so let's plug those values into the expression here in the question. Can I see you do that on the whiteboard?
All right. So, it would be like, okay, so 4, and so B is 1, so 4, and then over 2. Or I put B.
Yeah, I want you. Yeah, what are you plugging in place of B?
All right, so there it is, and then 2.
Good, looking good.
All right, so 4 times 1 divided by 2.
Okay, what does that give us?
So 4 times 1 is 4, and then divided by 2 is 2.
So what's the right answer?
So it'd be C.
Answer for C.
That's funny how it makes so much more sense, like, once you've walked through it, but when you first see it, it's like...
Looks terrifying. I mean, I remember being stumped by this. Just being like, I don't know what the operation is, right? And that's probably how about 99% of students look at me like, okay, what's the operation? What's the operation? What's it? No. Start thinking in concrete terms. Okay, let's see. Let's come up with some values for A and B. As long as A divided by B equals 2, you can use anything. Turn it to arithmetic. Okay?
Okay.
All right. Question number 9. Go ahead and read this guy for me, please.
All right. What is the solution, x and y, to the system of equations above?
Okay. You've seen system equations before, I assume. Is that correct? Okay.
Yes.
How comfortable do you feel solving systems of equations?
Not very.
Okay. I would say, in my experience, most students really, really struggle with systems of equations.
Yeah.
There's a lot of steps, a lot of things to kind of mess up. But I'd say in probably about half of the questions with systems of equations on the SAT, you don't have to do any algebra. We can solve this by turning the whole thing into arithmetic. How can we solve this by turning the whole darn thing into arithmetic?
Putting in variables.
Putting in numbers, right, in place of the variables. Okay. So how can we do that here with this question?
So we can make the x's like, I guess, 1s.
Now you could, but look, I mean, you could test a bunch of different numbers and see what gives you a true statement. Just coming up with some numbers and hoping that something works. You could do that, but I know x isn't going to be 1. How do I know x is not going to be 1?
Oh, because it has to equal negative 20.
I mean, well, no. Look at the answer choices, man.
Oh.
They give us 4 sets of possible answer choices. One of those sets is going to work, right? I mean, like, this is going to be the x value right here. This is going to be the y value right here.
Okay.
So we're very limited, and that's good news, right? We're limited with what x and y can be. We just test them, plug them in, see what gives you a true statement. Does that make sense?
Yes.
Okay.
So then would that mean we would want to put in negative values for the variable?
Well, I mean, like, look, x is going to, let's test the answer choice A. Let's see if answer choice, don't worry about, like, what are x and y? Don't worry about that. Don't worry about trying to solve it. Just be like, could it be answer choice A? Could x be negative 5 and y be negative 2? Right? Because that's an ordered pair. Right? Do you know what I mean when I say ordered pair? Again, that's the x value, that's the y value.
Okay.
So we can test it. Plug in a negative 5 for x into the equation. Plug in a negative 2 for y into the equation. See if it gives you a true statement. Does that make sense, Caden?
Yes.
Okay. Let me see you do that right now here on the whiteboard.
All right. So 3. So 3 times negative 3 times negative 5 plus.
Now, here I'm going to stop you real quick. So I've seen you been doing this quite a bit with multiplication. I'm going to recommend that you use parentheses.
All right.
Okay, just because when you start doing like multiplying negatives, yeah, and you got a multiplication sign and a negative sign there, it's going to be very difficult. So I'm going to recommend just in general that you turn that into. So I would rewrite that whole deal.
Okay.
Please do. So just it would be 3, and then in parentheses negative 5.
All right. So 3.
Have you seen that before, right? Where the parentheses means multiplication?
Yes.
Okay.
5. So 3 negative 5 and then plus 4. All right.
Okay. So we got 3 times negative 5 plus 4 times negative 2. And what does that equal, Caden?
So 2 times negative 5 is 15 plus 4 times negative 2 or negative 8. So that would be negative 23.
Yeah, it's negative 23, right? Because we get negative 15 plus negative 8. Right? And when you add a negative, right, that's the same as subtracting.
Yes.
So that gives us a negative 23. So we get a true statement so far, right? Because we're testing that first equation up there, right?
So A could work.
So A could work. Let's plug it into the second equation below that, right? And let's see if that works. And I'll clear some space here on the whiteboard.
All right.
Okay.
Well, then it would be 2 and then y. So y is negative 2. So and then the draw, right?
Good. I'm glad you're putting the y in there, right? In the first equation, the x appears first. In the second equation, the y appears first.
Yes. So then x is negative.
Good.
Okay.
Okay. Now we're subtracting a negative here, right? And so this is a good little review of arithmetic, right? What do you do when you subtract a negative?
So when you subtract a negative from a negative, then it's kind of like adding?
Yeah, when you subtract a negative, you're adding. And the example I use with students is like, let's say you've got like credit card debt. You've got like $10,000 in credit card debt. Okay, a lot of credit card debt. All right, if I take away your debt, if I take away your negative $10,000 from your bank account, it's the same as essentially giving you $10,000.
Right. All right.
It's like I'm adding 10,000 to the guy, right? So when you take away negative, you're adding, right? If there's a bunch of negative things in your life and you get rid of them, that's a positive thing, right? When you take away the negatives. Does that make sense?
Yes.
Okay, anyway, just an easy way to kind of remember that rule. All right, so what does that equal?
So then it would be 3.
Well, here, this is 2 times negative. What's 2 times negative 2?
Oh, 2 times negative 2.
Right, that's going to be negative 4.
4, right?
Right, yep, a positive times a negative is negative. So it's going to be 4 plus 5, or negative 4 plus 5, which is just regular 1. I mean, you could even kind of look at this expression right here, and even if you're not super comfortable with all of the arithmetic, you could be like, well, is that going to be negative 19? And the values just aren't big enough for, even if everything was going to be negative, the biggest, it wasn't going to give us negative 19. The numbers just aren't that big. Does that make some sense when I say that?
Yes.
Like, I mean, you can solve for what it is, or you can just say, is that going to give me negative 19? And there's no way that's going to give me a negative 19. Just in case you're iffy about the arithmetic. Does that make sense?
Yeah.
Okay. Okay. All right, so we can eliminate answer choice A. It's definitely not A. What about B? Let's just do the same thing. Plug it in.
All right.
So we're plugging in a 3 for x and a negative 8 for y. Good, looking good. Looking very good. See how useful those parentheses are now?
Yeah. Makes it a lot cleaner.
Yeah.
All right. So then just do that. So that's 9.
Yep, so that gives us 9 right there. 9 plus what?
So back to the order of operations.
Yeah, absolutely.
I would multiply first.
Absolutely, right. It's PEMDAS, right? Parentheses, exponents. There's nothing to simplify within the parentheses here, right? You might be like, well, there's parentheses. Okay, yeah, there's parentheses, but there's nothing to simplify inside them, right? If there was like a 3 plus 1 here, then we could add that, and that would be the first thing to do, but that's not the case. So parentheses, exponents, multiplication is the next thing. So start by multiplying before you do any other addition or subtraction. So you got to multiply that 4 times negative 8. Absolutely.
So then it's negative 32.
Negative 32.
All right.
Mhm.
So that does equal out to negative 23.
That does, yeah. That is negative 23. Okay, so we can test the first one. And by the way, when you're adding a negative, it's the same as just subtracting. So
right.
if you're adding negative things to your life is more negative. Right? If you add debt to your life, you have less money in your bank account. Yeah, and strangely, it kind of works on a logical level too. All right, so let's test. So the first equation works. Let's test the bottom equation. That 2y minus x equals 19.
So 2y is 8.
Does it make sense what we're doing here?
Yes.
Okay. You see why you don't have to play. I'll see if 1 and 1 works. I'll see if 0 and 1 works. You don't have to do any of that. They're giving you a limited number of x and y values. Just test the x and y values they give you.
Yeah. I don't know why I was doing that.
Yeah, you're good. You're good. I mean, because that's what I've been showing you to do up to this point, right? Is like coming up with your own values. And sometimes you do. Sometimes you do have to come up with your own values, and it makes more sense to do that. Sometimes you've got to use the values they give you with the question, and it varies. That's why that's why I can't just like tell you the strategy and then you're done. It's like you got to see what it looks like in the questions. You know?
Yeah, you got to recognize what you're looking at and then go from there. All right. Okay.
So it's 3 times minus 3. Okay, and what is that?
So that.
What's 2 times negative 8?
2 times negative 8 is a negative 16.
Negative 16.
And then minus 3 is negative 19.
Negative 19. Is that a true statement?
Yes.
Sure is.
That matches up with the thing.
Answer choice B. Done.
B.
Done. Don't complicate that. You could test all the others, but I wouldn't worry about it here. I mean, I'm a big fan of testing answer choices, and especially if you have time, great, cycle through all of them. And heck, if you have time to go back and you want to eliminate C and D with absolute certainty, because sometimes we make mistakes, it's not a terrible idea, but I'd feel pretty confident stopping right there when I found something that works. Okay? But in general, do be aware, I would say in general, especially if you're coming with your own values, you might get multiple answer choices that give you a true statement. Be aware of that. So I really do recommend, in general, I recommend testing everything when you're bringing in your own values. Once the answer choices that you're plugging in, you might be okay. You should be. All right? Okay. All right. Let's go to the next problem here. All right, go ahead and read question number 11 for me, please.
In the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken?
Okay. Caden, what did we solve for here with this question?
What was the price per pound of beef when it was equal to the price per pound of chicken?
Yeah, the price per pound of beef when it was equal to the price per pound of chicken. Okay, and we see these variables up here as B and C, right? B is the beef value, and C is the chicken value. Okay, so one of those two values equal. So there's some number of weeks after July 1st when those are equal.
Okay.
Okay? Okay. Now, there's an algebraic way to do this. Okay? Which, you know, a lot of students probably approach it that way. Right? You can set both equations equal to each other. Right? Find it like when the B value equals the C value, both sides of the right-hand sides of the equation have to equal each other when B equals C, and then you can like isolate X, solve for X, and then plug that back into the equation. You can do all that. That's an option. Okay? But there's an easier way to do this, which is just testing values for X. Right? We'll just test some number of weeks and see when the B value equals the C value. And we're just doing arithmetic.
All right.
Does that make sense?
Yeah.
Okay. Now hold on. Before we do that, look at the answer choices. Look at the answer choices, Caden.
Okay.
Are we talking about a very large number of weeks here, or are we talking about a relatively small number of weeks?
Small number.
A relatively small number of weeks, right? Yeah.
Yeah.
Right. I mean, because the highest value is like 335. So we're not, you know, X is not going to be like 17. You know what I'm saying? Like, it's going to be a single-digit number. It's probably going to be pretty small. In fact, it can't be bigger than 4, right? Because I'm looking at the first equation up here, right? And when X is 4, the B value would be 335, which is the highest value here in the answer choices, right?
Yeah.
4 quarters is a dollar, right? So it'd be 335. So it's nothing bigger than 4. So it's somewhere between 0 and 4.
Okay.
Right? And probably not 0, because I'm looking at that right now. When X is 0, beef would be 235 and chicken would be 175. So let's test values between 1 and 4. Does that make sense?
Yes.
Okay. Great. Right, and that's just kind of thinking about these things this logically and thinking in concrete terms. Okay, so I'm going to let me plug these in.
Okay.
Okay. And I'm just going to plug in, I'm going to test when X is 1. Okay, into these equations. Okay. So we're going to find the beef value here. So B is 235 plus 0.25 times 1. Okay.
Okay.
What is the beef value when X is 1, by the way?
So
you can,
yeah,
you can do this mentally, or if you know, this is a no calculator section question, by the way, so this you'd actually have to work out with the decimals. You know, I'm not too worried about the arithmetic right now with decimals. If that's something that you need to look up, do a quick YouTube search for like adding decimals or something like that. I just don't want that to be sort of that's not within the scope of this course here. But what does that equal? What is it?
2.6.
Yeah, 2.6, or I would describe this as 260, right? Because let's think in concrete terms. That's $2.60. $2.6 is $2.60. Does that make sense?
Yeah.
And I like thinking I like thinking about change. Like, if you asked me, if you said, Mr. Tweedy, what's 2.35 plus 0.25, I'd be like, But you said, hey, what's 235 plus a quarter? I'd be like, oh, that's like, that's 260, right? I've kind of changed before. I used to work at Starbucks. I mean, like, I know, you deal with money, I deal with money, you know. So, again, think in concrete terms. I think that actually helps. All right, so when X is 1, the beef price is 260. What's the chicken price? Well, just plug it into the equation here. So it's 175 plus 0.40 times 1. What does that give us?
That's 210. Or no, wait.
You're close.
Oh, the 5, 215.
215. Yeah. Yes. Not 260, by the way. At the very least, like you'd be like, I don't. You could be uncertain about it, but like, is it going to be 260? No, it's not going to be 260. That are equal. So X isn't 1. And by the way, we know we can eliminate out. We can eliminate answer choice A, because when beef is 260, chicken's not 260, so A is gone. Right. Does that make sense?
Yes.
Okay. Great. All right. Let's test when X is 2. Okay, so the beef is going to be, 235 plus 50 cents, exactly, right? And what's that equal?
285.
It's 285 for beef. What's the chicken?
That's adding 80 cents. So $2.55.
So it's 255. Are they equal?
No.
No, right? Then answer choice B is gone as well. Because when beef is 285, chicken's not.
Yeah.
Not 285. So, all right, looking good.
C, that wouldn't make sense because it's not.
We don't even have to test it.
Yeah.
Like, I don't think we can make the beef price even equal $2.95, unless we're talking about like some fraction of weeks, which I don't think we're dealing with here. We're not. Does that make sense?
Yes. So that means we can just take that one out.
It's gone. I mean, you can. D is looking pretty good, but that would be when beef is at the price of beef at 4 weeks. So let's try that.
Okay.
$2.35 plus $1, right? 25 times 4. It's $3.35.
Right.
That's the beef price. What's the chicken price?
Chicken price. So that would be
4 weeks. Yep. So that's gonna be one. That's gonna be 160. 175 plus 160.
So it's $3.35.
$3.35. There you go. We can confirm it. Steve. Any questions about that?
No, that's pretty laid out.
Okay. So this, by the way, again, these are all from the same practice test, from the same section. All the questions we've done so far. This is SAT practice test number 1, section 3, the no calculator section. All these questions. And over half of them involve this strategy of plugging in values for variables. Or at least half. Yeah. So,
All right.
you can. This is just nothing outside your skill set. Nothing.
Right.
Nothing.
That's cool.
Yeah. Okay. I mean, even if you're not a strong math student, which I think you would agree, right? Like you struggle with math, but if you can think, if you got common sense, you can figure all this out. Yeah. Let's do one more. I think we'll take a little break here.
All right.
Yes. Love this one. All right. Go ahead and read question number 13 for me, please.
All right. If x equals more than 3, which of the following is equivalent?
Okay. If x is greater than 3, which of the following is equivalent? Now, I think I said in that one of those questions there with the a over b equals 2, I said, always work within the limits of the question. Okay?
Right.
There's one exception to that, and that's for equivalent expression questions, like this one right here. Do you know what equivalent means?
The equal.
Equal to, right? So they're asking us here, which of the following expressions is equal to, is the same as this guy right here. 1 over x plus 2 plus 1 over x plus 3, that whole mess. Okay? One of those answer choices, A, B, C, or D, is equivalent or equal to that expression. Does that make sense?
Yes.
Okay. And because of the nature of the question, because it's an equivalent expression question, because one of those expressions is equal to that, it doesn't matter what x is for the equivalent expression. If they're truly equivalent, if they're truly equal expressions, x could be anything, and you should get this. They should equal each other. Does that make sense?
I think so.
Okay. Well, at the very least, I mean, you take my word for it right now, but like if two equations are equal, if two expressions are equal,
Yeah.
it shouldn't matter what the value for the variable is, as long as you plug in the same value in. I mean, like, maybe I can give you. Let me give you an example here. So, like, we've got 2x. If I said 2x is equivalent to 4x over 2, okay, those are equivalent expressions, by the way.
Right.
Right. It doesn't matter what x is. Plug in any value for x, and you should get a true statement as long as they're equivalent expressions, which they are. So, like, make x equal 1, you get 2 equals 2 equals 2 when x is 1. If x is 0, you get 0 equals 0. If x is 2, you get 4 equals 4. You get a true statement as long as they're equivalent expressions. Does that make sense now?
Yes.
Okay, good. Yeah. Okay. So it shouldn't matter what x equals here if it's truly an equivalent expression. Does that make sense?
Yes.
The only reason they're saying if x is greater than 3 is they don't want you to use the strategy I'm about to show you. Because it's so effective and it simplifies it so much, if you can do arithmetic or any operations with fractions, you can solve it. Okay?
Right.
So we're going to set a value for x. Let's do that.
Okay.
We're going to create a value for x. I'm going to plug it into this expression right here. We'll find out what that equals. Okay? In fact, I'm going to make x equal 0. We can do 1. We can do 2. I think 0 is just the easiest. Okay? So we're plugging 0 into that expression. We're going to plug that same value into the answer choices, and whatever that expression of the question equals, we should get the same value for the correct answer choice.
Okay.
Does that make sense?
Yes.
Okay, and I'm going to show you exactly what it looks like right here, so let's do it. All right, so let's plug a 0 into that expression. I'll plug it in, but I'm going to ask for your help to sort of as we simplify this thing. So we get 1 over 0 plus 2 plus 1 over 0 plus 3. Okay, so we've got a fraction here divided by a fraction, or two fractions divided, or a fraction divided. Yes, we've got two fractions in the denominator. We'll say that. All right, so okay, and then that simplifies. I'm just going to turn that 0 plus 2. I'm just going to turn that into a 2.
Yeah.
And that 0 plus 3. I'm just going to turn into a 3.
All right.
Okay, now we got to talk about operations with the fractions now. Okay. Do you know how to add fractions? Yes or no?
Yes.
You know how to add fractions. Okay. Okay. How do you add 1/2 plus 1/3? How do you do that?
You would have to make the denominators the same.
Yeah, you have to have a common denominator. Okay. What's the common denominator going to be for 1/2 and 1/3?
6.
Yeah, the common denominator is going to be 6. And so what's 1/2 with the 6 in the denominator going to be?
3 over 3 over 6.
Yeah, it's going to be 3 over 6. Let's just kind of rewrite this. 1 over 3 over 6. And then 1/3 with 6 in the denominator, what's that going to be?
2 over 6.
2 over 6, right? And that you might be able to just kind of like feel that one out, kind of logically, you know what I'm saying? Like what's 1/2 with the 6 in the denominator? Like you don't even have to do a calculation. It's like, would it be 3? Yeah, 3 divided by 6, right? It would be the same thing. They're both 0.5. If you're going to express them with decimals. Which I love, by the way, if you can just kind of feel it out and just intuitively express those with a common denominator. I also want to show you the right operation, which is if it's a more complicated fraction, you're probably going to want to know what the right operation is. So in order to express those with a 6 in the denominator, let me show you real quick. I'd multiply 1/2 by 3 over 3. Caden, what's 3 divided by 3?
That's just 1.
That's just 1, right? So if I multiply 1/2 by 3 over 3, I'm not changing the value of 1/2. I'm just multiplying it by 1, right? Anything by 1 multiplied by 1 is itself. Does that make sense?
Yeah.
Okay. So I'm not changing the value of 1/2. I'm just changing the form of 1/2 when I multiply it by 3 over 3. Does that make sense?
Yes.
Okay, good. And then when you're multiplying fractions, just multiply across the numerator and multiply across the denominator. 3 times 1 is 3. 3 times 2 is 6. You get 3 over 6, which is what we started with. Does that make sense?
Right. Yes.
Okay. All right. Same thing here with 1/3. How do we express that with a 3 or a 6 in the denominator? Well, multiply it by 2 over 2. What's 2 divided by 2, Caden? What's that equal?
2 that's just 1.
2 divided by 2 is 1. Absolutely. Right. So 1/3 times 1 is still itself. I'm not changing the value. I'm just going to change the form. Multiply across the numerator. I get 1 times 2, which is 2. I get 3 times 2, which is 6. I get 2/6, right, which is equivalent to 1/3. All right, now that I've got a common denominator, I can add these. Do you remember how to add fractions, Caden?
Yes.
Okay, how do I add fractions?
You add the tops, but...
Yeah, add the top, keep the bottom. So we get 5 over 6, right? Any questions about that?
No.
Okay, now, hold on, we got to talk about dividing by fractions. How do we divide by a fraction? It's a little bit trickier.
We have to so we would take the above fraction, or the above number, and we would have to make it a fraction.
We can. I don't think we need to here. I don't think we need to. I mean, when you divide by a fraction, you're just multiplying by the reciprocal of the fraction in the denominator.
Okay.
Are you familiar with that operation? Have you heard that before?
I have, but it's
been a while. Yeah, it's been a while. Okay, no problem. That's why we're going over this. 100%. Why we're going over this. All right, so we need to divide 1 by the reciprocal of 5 over 6. What does reciprocal mean?
I'm not sure.
Okay, reciprocal means you flip the numerator and denominator.
Okay. Yeah, all that, the terms are...
Yeah, no problem. No problem. You're good. That's why we're going over it, buddy. So you're good. All right, so we're going to multiply 1 by the reciprocal of 5 over 6. Reciprocal, again, flip the numerator and the denominator. So that's the same as 1 times 6 over 5. I've flipped the numerator and the denominator around. Does that make sense?
Yes.
Now you're talking about turning the numerator into a fraction, which you could do. I mean, 1 is the same as 1 over 1. And then you're just multiplying across the numerator and multiplying across the denominator. That works. That's fine. But you don't even need to do that. I mean, anything times 1 is itself. So what's 1 times 6 over 5?
So 6 over 5.
6 over 5, right? Okay? So we can say comfortably that when x is 0, the expression of the question equals 6 over 5. Does that make sense?
Yes.
Okay, great. So let's do that. Let's plug in that 0 for x, plug that into the answer choices, find out which one gives us the 6 over 5. Okay? Now before we do that, I can look at two answer choices. And without even doing any calculations, I can just look at them and say, I know those answer choices, two of them are not going to give me 6 over 5, and I can eliminate them. Which answer choices can I eliminate?
Wait, I'm kind of getting lost.
Yeah, you're good. So when x is 0, I know two of these answer choices are not going to give me a fraction of any sort, let alone 6 over 5.
All right, so it would be the C and D.
C and D? Absolutely. C and D are gone.
Yeah,
they're not going to give me fractions.
Yeah.
And I can look at this right now and tell you what C is going to be. C is going to be 5 when x is 0. Right? Because 2 times 0 is 0. 0 plus 5 is 5. Does that make sense?
Yes.
And it's just not a fraction. Now, if I were plugged in a fraction of some sort for x, okay, maybe a different story. Then any of these could be fractions. But I'm plugging in a 0. C's not going to give me a fraction. D's not going to give me a fraction. I can look at D right now and tell you what that's going to give me too. What's D going to give me when x is 0? You can tell me.
Okay.
When x is 0.
When x is 0, so then it would just be 6.
Just be 6, right?
Yeah.
It's not complicated, is it?
No.
No. You just got to look at it the right way.
Yeah, you just got to, once you see it the same way. Then
Yeah, that's it. And again, that's what I'm trying to teach you right here too. Again, it's not an operation. I mean, there are math concepts. Yes, there are. I mean, you have to know how to add fractions. You have to know how to divide by fraction. You got to know that. Okay. I mean, but that's like 6th grade stuff. You know what I'm saying? That's the middle school arithmetic. You can do that. Almost anybody watching this video could do that. But it's a way of looking at it. That's what I'm trying to teach you. You don't even have to calculate everything here. You can eliminate C and D right off the bat once you realize that there's no way C and D are going to give you a fraction. And if you needed to, yes, you could calculate them. You can calculate them by just looking at them. C is going to be 5. D is going to be 6 when x is 0. Easy. Okay? Any questions?
Yeah.
It's either A or B. Okay, so let me clear some space here on the whiteboard. We'll plug in a... in fact, let's do this. And I just want to make it real clear. We're going to get 6/5 when x is 0. All right, so let's plug in a 0 into answer choice. Well, which one do you want to test? A or B? Which one do you think is more likely going to be 6 over 5?
Probably B.
Probably B, right? So I'll plug it into B. Let's see what we get. Let me see you do that on the whiteboard.
All right, so x is still going to be 0.
X is 0, still. Mm-hmm. Yep.
So,
That's why I like setting that value, make it really clear sort of at the top.
all right. Yeah, I already see.
Okay. What's it equal?
It's just 6 over 5.
6 over 5. There you go. Can we eliminate A? What's A going to equal?
5 over 6.
So 5 over 6. Easy. We can confirm it's answer choice B.
Yeah. Huh.
Any questions about that?
No.
For any equivalent expression question, you can plug in values. You don't have to do any funky operations with variables.
All right.
Ever.
That's all right.
It's great news. Because this is a tough looking question. This is a tough question. Most students are not going to solve this.
Yeah.
This is a very high level difficulty question. Okay. But always be aware, they like doing this. They like saying, if x is greater than 3, x is greater than 4, trying to throw you off, right? They're trying to keep you from doing this strategy. But you know better now.
Yeah. No.
If you understand what an equivalent expression means, x can be anything. You can really simplify this. Any questions?
No.
Okay. How are you feeling about the SAT right now, Caden?
Well, a lot better now.
Good. You should. If you approach it the right way, you don't have to learn a whole lot of new concepts. Yeah, there's some things. I mean, and there's we're going to see some different question types. But again, this strategy applies to I mean, at least a third, between a third and half of the questions on the SAT, depending.
Yeah,
So
it's a good amount.
it's a lot of them. Yep. Yeah, and there's always a way to simplify them, even no matter what concept is being tested on, with a few exceptions. A couple of them, you just got to crank out the operations. Okay, like if it's a quadratic, if you got to solve like a quadratic expression, okay, sometimes you just have to crank out the operation. But that's a small number of questions. In the vast majority, there's simplification strategies like the ones I'm showing you here that apply. Okay.
Okay.
All right, let's take a little 3 or 4 minute break. You can run to the restroom real quick, grab some coffee. I'm going to probably do both, and
All right.
I'll see you here in just a couple minutes. Okay.
All right, sounds good.
All right. Thanks so much, kid.